Hello, everyone. Good morning. I am here to talk to you all about how we tricked our engineers into utilizing distributed tracing. So before doing that, I want to jump in and share a bit about me. I'm Noah. I'm an engineer at Strava, and I grew up in Ohio, which is a fact that I'm sharing because yesterday, about a third of the people I shared that with were somehow also from Ohio. And after yesterday's stats lesson, that naturally means that a third of the people at Monitorama and a third of the people interested in observability are also from Ohio. So I'm glad to share that fun fact with you all in case you were wondering. And many of these people, like I, have left Ohio, and I currently live in San Francisco. Before I was an engineer, I was also a swim instructor and a teaching assistant, which I am sharing with you because I've noticed that I've had some common threads throughout my life of things that I enjoy, and one of them is teaching. So whether I was teaching in the pool, teaching in college, teaching other students, or once I started working full-time, I noticed that I got a lot of fulfillment from helping other engineers and people around me grow and succeed, which was actually really helpful in the space of DevOps, SRE, whatever title we are currently giving ourselves. And yeah, so I wanted to share a bit of all of that with you all. So some of you may have heard the connection that building tools, doing dev tools, is similar to building tools for the product. We may roll our eyes a little bit about it, but at least I think there are actually some similarities, even if they're not the same. For one thing, we usually start also with research, and then we move on to an MVP and we iterate. And in our research phase, we look into what works for our customers, what our customers want, what their pain points are. The difference here is that our customers are other engineers, just like us, or maybe not just like us, but other engineers that will be using our tools. And then we move on to the MVP phase, get them to try out whatever it is that we built. And then we move on to the iterate phase where after we've tried it out, we adjust and hope they like it and then move on. Tracing feels different though. It weirdly feels like it doesn't fall into that category. And I think part of that is because there's this extra step of we need to convince people to actually use our tool, to actually use tracing. Tell them that tracing is amazing, and while we might believe that, and we might believe that all the tools we build are so great, it's not always such an easy sell to the engineers that we want to use it. They might not want to try something new out, they might be used to their old tools. So this extra step makes it feel really different. At least for tracing, it felt very different. Until I thought more about it, and I realized that basically everything that our team at least works on can, if I put it on a chart of what is fun and flashy and what is mundane, what gets people fired up and what does not, from the perspective of not us, from the perspective of the engineers using our tools, most things fall below the fun and flashy line. Most things are closer to mundane, most likely in this, I can use my laser pointer, in this third quadrant over here, in the not fired up area. Even though if I were to chart a lot of these things, and maybe if you all were to chart all these things, it may actually be all over. A lot of things might be up here or over here. So I realized that a lot of our job is not just building these tools, but convincing people to move over to this quadrant. Ideally, we can get them up here, and AI has managed to do that. People love AI. You just say AI, and they're on board. It doesn't matter what you say, which is great, and we should take advantage of that and use that to get people excited about things. But most things are not AI, even if they were AI for some period of time. And so it's our job to get people over here. We might not be able to convince them to go up here, and that's okay. We should be realistic and get that things that are really exciting to us, we might not be able to get people as excited, but we at least can get them interested in realizing why it's important so that they can move from, I don't really care about this and this isn't on my radar, to I'm fired up about this, even though I know it might not be the most interesting thing for me. So with that, how does tracing look at Strava? We started off in about 2019. We had a few really passionate engineers who decided that they wanted to introduce tracing. Tracing was a new tool. People didn't know about it. It wasn't something that people necessarily felt like they needed. So these engineers took it upon themselves to share with others why they thought it would be really helpful to them. And they were successful because they got buy-in to introduced tracing, and by the end of 2019, we had close to 100% adoption in terms of instrumentation. So it doesn't mean everyone was using it, it just meant that off the bat, tracing was very valuable to people because almost all of our like microservices had tracing. So when people wanted to use trace data, it was very helpful to them. Over the next couple of years, we saw a bit of an increase in tracing usage, but mostly we kind of had a like consistent group of people that were using it. Sometimes we'd get some new engineers that joined that were excited about it, but there wasn't so much churn of new people who were at the company, found out about tracing, got excited, and it wasn't like that number of adoption was always increasing. It sat somewhere between like 20 and maybe 30% of our engineers were using it, and then the ones who didn't use it had like never used it. It wasn't that they had tried it, it wasn't for them. They had like never opened up our tracing tooling. And for the most part, we were fine with this. We were like, it's really helping the people who are using it, and that's okay. Not all tools are for everyone. And so we didn't do much more than like having docs, having some tech talks. And then if we look ahead to, towards the end of 2023, we decided to migrate towards OpenTelemetry, and we noticed that we had an increase in adoption. Weird. That was not our plan. So we decided to look into this a little bit. So what exactly was this migration, and why did it cause an increase in adoption? And specifically, we actually saw a 50% increase in adoption. It was like pretty dramatic. We went from having like maybe 30-ish% of our engineering team using tracing to closer to 50%, a little bit over 50%. And more than that, the engineers that were using it for a meaningful amount of time. We could see about the average like session time in our tracing tooling, and it stayed the same. It was roughly 15, 20 minutes. So we're like, okay, people are like opening tracing and they're actually using it. Like, cool, what did we do? So what was this migration? And why did we do it? We migrated in the first place because we wanted to get onto industry standard software. We were using OpenTracing before, and there were third parties that were emitting trace data, and we wanted to utilize trace data, except they were like only in OpenTelemetry. And so we were like, okay, I guess if enough people are emitting OpenTelemetry data and we want this data, we should also make it so that at the very least we can accept OpenTelemetry data. So that's what we did. We set up a system where we could coexist with OpenTracing and OpenTelemetry, and we had our like internal libraries, build out this tooling, and all we had to do is go to our microservices that we had, upgrade those microservices, and then we'd be good. The problem is that we have 100 microservices, about 100, which is a lot to upgrade for a team of like about 6 or 7 people, where not everyone was actually working on this project. That's a lot to deploy, that's a lot to test, and that's everything that we own, and if we make a mistake, we break everything. And so we're like, okay, we should ask for help. So that's what we did. We reached out to other engineering teams, other managers, and we got approval for other teams to help us with this migration. So what did we ask of the teams? Our goal of what we asked of the teams is we wanted to, first of all, get things migrated, but we wanted to automate as much as possible. We didn't love that we needed to reach out to others and ask them for help. We would have rather had something just like ready out of the box that we could hand to them. So we were really focused on making sure we could automate as much of this as we possibly could and make it so that this wasn't a hassle for people and this wasn't a disturbance, and they can get back to their regularly scheduled program as soon as possible. The other thing that we wanted to do is make sure that we didn't break tracing. So for those of you that might be newer to tracing or have not used it, if you have a request, where's my pointer? Okay, so if you have like a request that comes in, it'll go to some services and some databases, and each of these things will emit traces. And someone mentioned yesterday, tracing is just fancy logs where you just are stringing them together. But the problem with stringing things together is if you stop stringing one thing together, the whole chain is broken. So if one team breaks tracing, it actually breaks it for anyone that touches their service. So it was important to us to make sure that however this migration worked, that it was happening with intention so that we didn't end up with tracing that didn't work, because out-of-date tracing is definitely better than tracing that doesn't work. So what the actual upgrade was is we asked people to bump a library where we had implemented all of the tracing instrumentation, deploy their service, and then test their changes. Seems easy enough, except for the fact that testing is actually a lot of work, which is why we needed help in the first place. It's a pretty heavy lift to make sure that everything is working, and It's hard to automate. We can't necessarily write out exact instructions because we don't know how all the services work. We were really relying on other engineers to understand how their services work, understand how tracing used to work, how it does work, and make sure that everything was passed on. Because while we added a lot of library code instrumentation, there were edge cases. We didn't account for every single thing that people had traced. People can manually trace things. People can trace third parties that only their service uses, and so we might have not had it in our library code. So I said we tricked people. Why did I say that? The trickery came from the fact that we increased adoption without telling people our goal was to increase adoption. Normally when you build a tool and you tell people, hey, I want you guys all to use this, at least in my experience, there's like a visceral reaction to that. It's like, ugh, I do not want to learn another thing. Whatever I have is working. It's a lot of work. I don't really want to do this, but if you'll make me, I'll do it. Ideally, we can have that be a like friendlier reaction, but if we're being realistic, we also don't like when people come to us and tell us we have to go do new things. It's not just other engineers. It is a like everyone problem that it's hard to learn new things. We like the things that work for us. So the trickery here is that finding a way to not actually tell people, I want you to spend time learning about this new tool or existing tool, learn more about it, and kind of just have it happen seamlessly in the background. Oh, sorry, I'm gonna grab some water. So another confession about this trick is that you might have noticed that nowhere in our goals was there increased adoption. So we didn't actually realize that we had pulled a trick until after the fact, but we did start noticing some symptoms of the fact that a trick was pulled. For one thing, we noticed that people started asking more questions about tracing. We noticed in our messaging channels that people were asking not just about the migration, but they were asking about how things in tracing worked. We noticed that after incidents, people included screenshots and links to traces, which besides that core group of people that were using it before, that wasn't really happening. And we started noticing people asking about adding more tracing instrumentation to components that they had added since our initial edition that didn't have them, which also wasn't something that had happened since like 2019. And the last thing that we noticed was when we set up office hours for our migration, and we also noticed that people in these office hours were stopping to ask about the actual migration and were actually just coming in for help to learn about tracing. And we're like, huh, that's interesting. I wonder what happened. And so when we looked closer, we saw that we had like a 50% increase in usage, and that's where all these questions are coming from. That's where all this new interest, it's those new people that were not used to this, were coming in, asking for support and for help. So what actually happened? The first thing that I think happened is people had time. People had time to focus on this new tooling. Normally, you put a tool out there, you tell people, hey, go learn about it, and while in our ideal world, we would love for people to go take in their spare time or in their free moments between projects, between meetings, that they just like spend some time poking around our tools. In reality, that's never what happens. But here, they had some time where they were actually focusing on it. On top of that, incentives were aligned. In order for people to get this task done faster, the task of migrating, it was in their best interest to understand how this tool worked, because if they didn't understand it, they'd spend more time fumbling around in it. Odds are they wouldn't do it right, and then we would come to them and be like, hey, stuff is broken, and now we need to work with you to fix it. So it was in their best interest to take the time to learn how this tool actually worked. And then the last thing was that there was interactive learning built into this. Every single service that got deployed turned into a functional, customized demo for individual teams. We had teams that, let's say they had 10 services they needed to deploy. So now they had 10 practice runs through a practice like walkthrough through our tracing, where they could go through, they understood, there was a lot of variables that they knew about. They knew about the service, they know how the service works, they know how it talks to other services, but they don't know about this tool. Rather than showing them this new tool and having everything be new, having them use dummy services, dummy variables, things that now they have to make meaning of everything, the only thing they had to make meaning of was just the tracing tooling. So what this ended up being is kind of like the perfect recipe for sparking curiosity on their terms in a way that was easy and more doable for them. We kind of like lowered the barrier of entry to learn about tracing. We said, let's take away as much of the unknown and a bunch of like the scariness, the things that we can make it so that it's harder to jump in, and make it more something that's custom for you, and then go forward with that. So while having these interactive demos is awesome, some of you may have like, I know we've tried to make interactive custom demos before that were like one-off demos. We ran into problems where people didn't find the time to use them. They took a lot of time to make, and they were hard to maintain. But in this case, they were kind of like one and done, and they were self-created on their own, because it was actual work that needed to be done, which was a great combination to have. So how was this different? We do a lot of migrations. We often need to ask for help from other people all the time. But most of the time, when we ask people for help, we're more in this fully automated category, more in this Waymo category. We try to package up as much as we can and write as much instructions as we can to be the least inconvenient to others as possible. And there's pros to that, in that it gets whatever you need introduced into your code base faster. But the downside is that it doesn't get people interacting and engaging with whatever you built. So even though we actually wanted to be on this fully automated side, out of like necessity, because we didn't understand how every single service worked, we kind of had to move more towards Taylor Swift over here and put people a bit more on their own. And that didn't mean that we didn't support them at all. It didn't mean that we didn't provide them with docs. We didn't provide them with help. We did. We provided with docs, help, tech talks, all of that. But there was still a level where we were like, okay, now this step of the instructions is you need to go through, understand how your service works in tracing, look through tracing, and see what's different. And we can't tell you that without literally doing it for you. So we pushed people a bit more out of their comfort zones, and out of our comfort zones too, because we didn't like having to ask that of other people. So how can we emulate this? How can we duplicate it? This happened to us in like a trick fashion, which is awesome, cool, happy accidents. When those things happen, it's really great. But when we're reflecting back on it, we want to be able to do it again and repeat it for future projects. So when I think about like how does a normal project work, I think you have like your initial work that you do, you start working on it, it's hard, then you're done. Well, you think you're done. Then someone reports a bug, and then you spend a bunch more time, get a few more bumps, and then you're actually done. Project's over. Great, move on to the next project. Except there's actually this extra peak that we don't tend to put time into, and this is the adoption section. And the reason why it's a peak in and of itself is that it is part of the project. It's just a part of the project that we don't tend to like as much. It's not as fun documenting things. It's not as fun not building things. It feels like you're done when you push your last commit and you move on, and you can move on to something else because you don't have to put all of your energy on it, which is true. But if you totally ignore this part of the project, the adoption, then you're kind of leaving a project half finished, and people can't use half finished things. So once you get to this phase, while you can slow down a little bit, this peak is smaller than the other peaks. It's still a peak that needs time. So in our case, what we did for this is we kept like one person fully on our project, and then other folks moved off of the project, but we're still available to help, and kept like some percentage of availability to help support in the adoption phase of things. And this is also slightly deceiving, because it seems like once the adoption is done, things are over. But as we see, it's kind of going up a little bit again there too. And that's just to say that while adoption will slow down, like the work you need to do for it, it never actually fully ends. There will always be more work to do, because you will never have 100% of people knowing and using your tool. And a tool that is not used is not a helpful tool. If you spend all this time building this tool, you want people to use it. You want people to know about it. And if they're not using it, it's functionally like it's not there. So what lessons did we learn going through all of this? The first is digging more into that point, and that is that you have to continue investing in adoption. It's not something that you can just like, when you water a plant, you don't just water it once and say, cool, I watered it, move on. If you stop watering it, the plant will die. And that's the same with tool adoption. If you provide resources that are really great, so you water it, you give it all the nutrients it needs, and then you leave and you get a sunny day, Now people might not be using your tool anymore, they might not know how to use it, and that tool will lose a lot of its functionality. So it's important to take the time and the resources and to kind of get that message back to your team and your managers that this is part of the work too. It's not just planting the seed, you also need to be there for like the aftermath. Even though that's like, might be less exciting for us, it's still an important part of the project. The next big thing I learned is, this is probably like the biggest thing I learned, is being able to trust my coworkers and trust the other engineers at my company. A huge part of like my internal challenge on this project was not wanting to inconvenience other engineers, not wanting to add any extra load onto their brains. And when I stepped back, I was like, we work with amazing engineers. We work with really smart people. Their jobs are literally to solve problems. They are capable of solving problems. And so while we shouldn't be like artificially creating excess problems for them, and we should be providing them with the support that makes sense to like help them do their jobs the best they can, it's okay to, when you're introducing things, to have work that they also need to do. And we can trust that if they get stuck, they'll tell us and they'll ask us and they'll reach out for help, and that we don't need to put in an extraordinary amount of work to make it so easy. And the benefit of that is that at the end, they would have engaged with whatever you built, and that would have made it more likely that they will keep using it. The last thing I learned is that it's worth it to get creative and get tricky with your solutions. So going back for a second at this graph, the adoption part of the project is a hill. It's not flat. This isn't like we write some docs, we do some known, simple, easy work. It's a challenge too, just like the rest of the project. So it helps to treat it like an actual part of the project, and to treat it by getting creative and thinking of how, like, what does your team look like? What are the engineers, how do the engineers that you work with work? How do they like to learn? What works for them? What hasn't worked for them? And realize that every project will be different. You might not be able to apply these exact techniques to your project, but you might be able to apply similar ones. So in the case of this like Rube Goldberg machine, hard to say, there's like a napkin that this guy's trying to use, and ideally he just reaches out and uses that napkin. And maybe one day he will, but in the meantime, we have this big complicated machine. We're doing some mental gymnastics to show him that this napkin is really helpful, and he will like using it once he starts using it. And that's kind of the same with our tools. Ideally, we give people tools and they, off the bat, just know that they're helpful and useful for them, but that isn't in line with what reality is. Most likely, people will not just pick up our tools and be excited about them. So instead, we should figure out how can we work with other engineers, find ways that work for them, that lowers the barrier of entry, gets them excited about tools. This could be things like embedding it into migrations. It could be things like setting up friendly competitions of like, let's see who can navigate through our tooling the fastest, and have some like fun prize at the end and have it be like a one-off thing. It can mean peering into what other teams are doing and figuring out when they're about to start a new project to build a new feature, seeing, okay, what tools do we think could help them that they don't use, and let's work with them and see, and like help them learn to use that tool in the context of their project. So not in the context of the whole company, just the team. And there's like countless ways this can be done. And again, not one right answer, but it's a challenge and worth spending the time to think about. I think it'll pay off in the end because, like I was saying before, a tool that is used in a tool that people know about is a helpful tool, and one that people don't use isn't. But one takeaway that I didn't write here is that the goal with all this is still not to get 100% of people using your tool. That will likely never happen, but getting closer to 100% of people knowing that your tool exists. Because they can always learn more about your tool once it's already out there and they know about it. But if they don't even know about your tool or don't know much about it, when it comes to them using it, they're likely not going to, and they're going to default to what they already have. And when you have things like tracing or things like monitoring tooling that people aren't forced to interact with the same way that they would be with, let's say, like deployment tooling or pager, like your pager alerts, people need to choose to interact with it. So it's our job to help people see why they should interact with it and make it easier for them. Thank you, and yeah, if anyone has any questions.
All right, we've got time for a couple questions. I see one right here.
Yeah, I feel like these blocks never really occur bars, and that you have peer pressure in your periphery, that if you didn't do the work, tracing would be broken for everybody.
Was there a question?
Yeah.
But I feel that's important, because we have the same sort of issue where I work, in that we can't get everyone to do tracing because there are so many spots where it's not being forced on them. So tracing doesn't work because one of them doesn't do it.
Gotcha. So I think the question was how do you get people to instrument the tracing? So tracing needs to be in a lot of places for it to work. And if you're missing some of the inner blocks, it doesn't work. So how do you get your team to use it in the first place? So what we did is we have a tracing instrumentation library code, and as long as people are generally using that library code, so for example, we have like a basic building block of what is a service and like what is a client, and all of our microservices use those building blocks. And as long as they're using those building blocks from our shared library code, they get some basic tracing for free. And that's how we do that. So if they're just using the basic library code, all they're doing is making sure tracing isn't broken for other people. And if they want to get more out of it, that's when they might need to invest more effort into it. But at least they're getting that bit of you don't break it for other people. And that part is the part that you like sort of force onto others, but they need to be using those things for other reasons anyways. So it's kind of, again, like finding a mix of like, where can we put this where people are gonna have to use it anyways, so that they don't really have a choice whether they use it, and they do have a choice if they use it further. So in our case, it was putting it into our library code that they already need to be using, and they already need to be upgrading for like security vulnerability reasons.
Another question right here.
So when it's in a shared library, like who owns that library?
Who owns the shared library?
We do. So yeah, who owns the shared library? We own the shared library, which puts then the incentive on us to have it be really modular, really easy to use, not something that we have to be fixing all the time. And that's also why we did end up needing to lean on other engineers for the migration, because it only handles the basic cases. It doesn't handle all the edge cases. If we're like, our services talk to SQL databases, that's common. We got that covered. If you go and talk to a different type of data store, we don't have that covered. You have to write your own tracing for that. So we'll own all the things that are like common, and then provide support for the things that are less common.
All right, I think we'll do one more. How about up front here?
The sampling turned out in your use case, are there any insights of how tracing help other engineer teams?
Wait, so are you asking, so how does tracing help other engineering teams?
Yeah, like does tracing really helps other engineering teams? How?
Yeah, so how does tracing help other engineering teams? So on top of, so there's like the use case that a lot of people are aware of, where there's an incident, where did that incident go wrong? But another huge use case that people at our company at least use tracing for is understanding our big system. I said we had 100 microservices. That's like a lot to wrap your head around. And having a place you can go to when you're going and building something new and seeing how does everything fit in together. And then when it's not working, you're able to understand like where is it supposed to fit in. So it's used both when there's a problem and then when people are building things, as well as when people are just trying to learn about this like new system they were just plopped into and trying to make meaning of.
All right, we are gonna head to break now, so you can actually find Noa in the back room area and ask her more questions. Also, a good reminder that we do have the speakers channels as well. Let's do one last big round of applause for Noa.